Hi, ho again, students. Mr. Kaczynski with you. Practice Your Skills 7.1 solutions coming at you. We'll try and attack this from graphical math, mental math, calculators. We'll try and do this a few different ways. Find each value for f of x equals 3x plus 2 and g of x equals x squared minus 1 without using your calculator. Then use your calculator to check your answer. And there's several ways we could use our calculator to check our answer. But all right, here we go. We're going to do f of 3 instead of f of x. Instead of 3 times x plus 2, it'll just be 3 times 3 plus 2. That x is just our input, okay? So f of 3 is going to be equal to 9 plus 2. F of 3 is 11. So the nice thing about function notation is that we can see the input and the output right there. When the input's 3, the output is 11. It's like an ordered pair too, 3, 11. All right, find x when f of x equals 2. Now this is a little bit different in that they're giving us f of x. Okay, so we're going to change that to 2 equals 3x plus 2. And we're going to find what x is, okay? So let's subtract 2 from both sides and then divide both sides by 3. And you can see that the answer is 0. In other words, when x is 0, y is 2. Let's graph this function. 3x plus 2. Actually, let's just, well, obviously it's a linear equation where the y-intercept is 2. So that answers the first question. When x is 2, the value of the function, or I'm sorry, when x is 0, the value of the function is 2. And then the other situation here is at 3, our output is 11. All right, but now they say, what about the value of the function g when the input is 5? Okay, so, or g of 5 is the way we say that. Instead of x squared minus 1, we would do 5 squared minus 1. So g of 5 would be 25 minus 1, which would be 24. So g of 5 is 24. What about g of negative 3? Well, same thing. Instead of plugging in x or 5, we're going to plug negative 3 or substitute negative 3 into this. Remember that that is a negative being squared, so that's 9. So g of negative 3 is 9 minus 1, or 8. All right, so let's graph that second function. X squared minus 1. Let's see what we can get off the graph. There's that parabola. It's what we call a quadratic function. We're going to work with that more later. G of 5 is not going to show up here, but what about negative 3? There's the 8 right there. If we go to the table, we can see 5 gives us 24, and we can also see the negative 3 gives us the positive 8. Moving on, f of negative 4. All right, that's going to be 3 times negative 4 plus 2, which is negative 12, plus 2, which is negative 10. So check that real easy. Negative 4, negative 10. There we go. G of negative 2. That means we're going to do negative 2 squared as opposed to the opposite of 2 squared, minus 1. So that's going to be 4 minus 1, which is 3. Yeah, where's our negative 2? There it is. And there's our output of 3. X when f of x equals 11. So they're giving us f of x equals 11. That's our output's 11. Remember, our input is 3x plus 2. Subtract 2 from both sides and divide both sides by 3. We get x equals 3. So when we go to x3, do we get an output of 11 for f of x, which is where we put y1? Yes. And last one here, x when g of x equals negative 1. So negative 1 equals x squared minus 1. We're putting that in for g of x right there. Let's add 1 to both sides, and then we'll take the square root of both sides, or just ask yourself what number squared equals 0. Obviously, that is 0. And if we go over to 0 on our inputs, you can see you get an output of -1 for g of x. All right, moving on. Find the y coordinate corresponding to each x coordinate if the functions, we've got these two functions. So let's use pink for f of x, and we'll use green for g of x. Here we go. All right. Let's do this a little bit differently. We'll use the home screen here. We'll go -2 times x, which is 6, minus 5. And that gives us that the value of the function f at input 6 is -17. Okay. What about the value of function f at input 0? Don't we know that's going to be -5? I think we can use some mental math there, can't we? 0 times -2 is 0, minus 5 is -5. That's also known as the y-intercept. G of -2, or of g of +2. All right, I definitely need my calculator to do this. I don't know what they're talking about being able to do this without a calculator, but we're going to do 3.25 times 2 to the power of, nope, times 2.5 rather, to the power of 2. Yeah, so that's kind of an ugly number, 203.125. All right, what about g of -2? Notice how I'm saying that, g of -2. It's not g times -2. Well, let's do this, 32.5. Oh man, I messed that last one up, didn't I? I typed it in wrong. Let's try it again. 3.75. Come on. 3.75, not 32.5, times 2.5 to the power of 2. That gave us, okay, that's a different number. Let's fix this. $23.4375. When you're plugging in a negative number for an exponent, you might need to use parentheses on your calculator. Depends what model you have. A lot of the newer ones you don't, but if you got one of my old yellow ones, you might have to do parentheses -2, which is 0.6, so 0.6. F at -4. Oops. Don't want the highlighter, I want the pen. F at -4. All right, so we're going to do -2 times -4 minus 5, and that's 3. Here's another way we can do this. We could store -1 stored as x. We do it like that, and then we can put in this function 3.75 times 2.5 to the power of x, and it's going to raise it to the -1 power, which is 1.5. So g of -1 is 1.5. I'm going way calculator heavy here, aren't I? That's okay. F of 3, we'll use some mental math on the next one. Used red, but I wanted to use pink. There's a big difference between red and pink. F of 3. All right, well, we can do this one with mental math, or we could store 3 as x, and then do -2 times x, which is -6, minus 5 is -11. And come on, definitely mental math here, right? G of 0. Anything raised to 0 power is 1, and 1 times 3.75 is 3.75. X, or 0 stored as x, 3.75 times 2.5 to the power of x, 3.75, told you. All right. Use these functions. Now we got 3 of them, okay? So we'll go pink on this one, we'll go blue on this one, and we'll go yellow here on h of x. to find these requested values. All right, f of 11. That would be 11 minus 3 is 8. Half of 8 is 4. And 4 plus 4 is 8. So we're using some mental math there. And then g of 5. 5 plus 1 is 6. And 6 divided by 3 is 2. All right, and we're just going to add those up. And we get that the total value is 10. So the value of f at 11 plus the value of g at 5. All right, next up, g of 8. 8 plus 1 is 9, divided by 3 is 3. And then h of 2. All right, so 2 times 2 is 4, and 5 minus 4 is 1. And we're going to subtract those, so that should be 2. You guys can check the work with a calculator if you want to check my work. I'm not going to slow down here. I'm going to let you guys check me out. All right, f of 3. 3 minus 3 is 0. Half of 0 is 0, plus 4 is 4. G of 2. 2 plus 1 is 3. 3 divided by 3 is 1. And h of 1. 2 times 1 is 2. 5 minus 2 is 3. All right, so we're multiplying all these. 4 times 1 is 4, times 3 is 12. Hopefully with the color coding, you can see where everything's coming from here. F of negative 1. Negative 1 minus 3 is negative 4. Half of negative 4 is negative 2. And 4 plus negative 2 is just 2. Minus g of negative 1. Negative 1 plus 1 is 0. And 0 divided by 3 is 0. So we're going to subtract the 0 from the 2, and we get 2. H of 2. 2, well, we already did that one right here. It's 1. Work smarter, not harder. And then g of 2. 2 plus 1, we already did g of 2. There it is. It's 1 again. So this time we're doing 1 plus 1, which is 2. Getting a lot of 2's as our answer. G of negative 4. We haven't done that one yet. Negative 4 plus 1 is negative 3. Negative 3 divided by 3 is negative 1. H of negative 4. 2 times, well, how about negative 2 times negative 4 would be 8. So we'll do 5 plus 8, which is 13. And then negative 1 plus 13 is 12. All right, so order of operations. You got to figure out the value of the function before you figure out the value of the entire expression. All right, now we're going to use a graph. We did a lot of this in the lesson today. Use the graph of f of x to find these values. All right, how about f of 1? At 1, we get an output of negative 1. What about f of 5? All right, so we'll go to 5. Oops, yeah. And at 5, the output is 4. I guess I could have done a better job of labeling the first one. The reason it's negative 1 is because there's the output. X when f of x equals 0. Okay, so when the output is 0, all right, wait, sorry, going backwards here. When the output is 0, what's the input? And that looks like it is at about 1.5. I'm going to say x equals 1.5. So at input 1.5, we get an output of 0. F of 2 plus f of 3. All right, f of 2 is 1. And f of 3 is 3. So together they make 4. X when f of x is negative 1. So we have to go to the output of negative 1, which is right here. And we already know that this is, I mean, we answered this up here. It's 1. X equals 1. Okay, because that's our input of 1. You know, really, I guess we should have done this in the same exact color, shouldn't we? Because it's the same answer. This is going to be x equals 1. When x is 1, the output is negative 1. When x is 1, the output is negative 1. X when f of x equals x. Ooh, interesting. X when f of, where are they equal to each other? Right here. Are there other places where they're equal to each other? So we've got x at -2. That's one answer. I think there's another spot. Yeah, we even saw it, didn't we? Yeah, f of x. When f of 3 is 3. So there it is right there. So those are the two spots. It's actually two solutions, two values of x where the input equals the output. Number 5, f of 2 plus g of 2. All right, well, let's go to f of 2. That's right here. And that gives us 1. G of 2, now we'll stick with the pink. G of 2, got to go up here, and that takes us across to 3. So we're going to add those up, and we get 4. F of 4, so we got to go up to the black function there, and that looks like it's 3.5. And then G of 4, that's shorter, that's at the 3. So we're going to multiply those. 3 times 3.5. 3 times 3 is 9. 3 times 0.5 is 1.5, so call it 10.5. F of x equals g of x. Where are they equal to each other? Where do they cross each other? Looks like they're going to right there, but I know that they cross each other right here. So that's at x equals 3. Do those two functions intersect each other anywhere else? Not that I can tell. So just at 3. And x, when g of x equals 2 plus f of x. That's kind of crazy. So when is the g of x 2 above the f of x? I need to get rid of all this stuff out here so I can see this a little bit better. When is it 2 above? When is g of x 2 above? Right here, it's 2 above. And also right here, it's 2 above. So I think the answer is when x is -2 or when x is 2. Those are the two spots where the red function is 2 above the green function. In other words, you have to add 2 to the black function. Did I say green? You have to add 2 to the black function to get to the orangish function there. All right, if f of x is a linear function with f of 2 equaling 5 and f of 6 equaling 11, write the equation for f of x. Well, they've essentially given us 2 points here. 2, 5, when the input is 2, the output is 5, and 6, 11. When the input is 6, the output is 11. So from that, we can figure out slope. 11 minus 5, that's the change in y, over 6 minus 2, that's the change in x. So that gives us 6 over 4, or 3/2. And now we just need to figure out the y-intercept. So how about we do that by going y equals mx plus b. So we can take either of these points. I'll plug 5 in. 5 equals 3/2. That's the slope we just found. We're going to put in the x value, 2, and that'll help us figure out the y-intercept, b. All right. So 3/2 of 2 is 3. And when we subtract 3 from both sides, we get 2. So that's our y-intercept. And now we can write our equation. Y equals 3/2 times x plus 2. We're definitely going to check this one to make sure we did it right. So let's go into the calculator. Let's go to y equals, clear these old ones. Put in our equation, 3/2. I am going to make a correction to this too. 3/2 x plus 2 table. So at 2, do we get an output of 5? Yes, we do. And at 6, do we get an output of 11? Yes, we do. We must have the right equation. I am going to change one tiny thing here. And I'm going to change that y to an f of x. F of x equals 3/2 x plus 2. The whole thing is linear function. I guess we might as well write, or as function notation. So we'll write it in function notation. And the main thing to this problem is just realizing that, oh, they gave us an input and output, and they gave us another input and output. If we have 2 points, we can write the equation of a line. All right, I hope that was helpful to you. Ask